Amines can be prepared from the nucleophilic substitution of haloalkanes. The formation of primary amines is when our haloalkanes reacted with the excess ammonia. Ammonia will lose one of its hydrogen and our haloalkanes will lose its halogen group. For the formation of secondary amines by nucleophilic substitution of haloalkanes, the haloalkanes will react with a primary amines. Okay, so dekat sini we have a primary amines. Okay, so in this reaction, our primary amines will lose one of its hydrogen on the nitrogen. Okay, hydrogen ni mestilah pada nitrogen, and also haloalkanes macam biasa it will lose its halogen group, and then kita combinekan sahaja the structure, we will get a secondary amines. So for example here, okay, so our haloalkanes here will lose the Br, and then our primary amines akan lose one of its hydrogen on the nitrogen atoms. So combine the structure, so kita akan dapat CH3, okay, from this structure, and then combine je dengan the nitrogen. Okay, we have the nitrogen HCH3. So we can see that one of the nitrogen on our primary amine ni tadi dia dah hilang. Okay, so dia gantikan dengan CH3. So we have two alkyl groups on the nitrogen, right? So it is a secondary amines. To form a tertiary amines from the nucleophilic substitution of haloalkanes, our haloalkanes must react with a secondary amines. Alright, so since on the secondary amines we have only one hydrogen on the nitrogen atoms, so we are going to remove this hydrogen and remove the halogen from the haloalkanes and then combine these two structures. We will get a tertiary amines. Alright, for example here, okay, our secondary amines, remove the hydrogen, remove the halogen from the haloalkanes, and then we are going to combine the structure. Okay, so we have CH3. Okay, CH3 from our haloalkanes, it will combine with the nitrogen on our amines. Okay, nitrogen, and then just salin je balik, copy back all the things here. Okay, so here we have a CH3. So you can see that we have a tertiary amines from the reaction of haloalkanes with secondary amines. Next, we have the reduction of nitrous compound. So the reduction of nitrous compound will produce a primary amines. Okay, so the reducing agent that can be used is hydrogen in catalyst such as nickel, platinum or palladium, lithium aluminum hydride followed by hydrolysis, and also sodium boron hydride in methanol. So for this reaction, okay, so mana-mana reducing agent pun boleh kita pakai. Okay, so in this reaction, the carbon triple bond end will be reduced into CH2 and H2. So kita just tambah dua hydrogen on the carbon and also dua hydrogen on the nitrogen. Alright, so for example here, for this compound, okay, so kita salin je balik our structure. Alright, so here we have a cyclopentyl. Okay, on this carbon we have C and N, the nitrile group, and then here we have the OH, right? So the C triple bond and here will be reduced into CH2 and H2. So since here we have a secondary alcohol, OH group attached to the secondary carbon. Okay, so since secondary alcohol does not undergo reduction, so tak ada apa-apa lah berlaku pada OH group here. And then we have a reduction of amide by using lithium aluminum hydride followed by water as our reducing agent. Okay, so to form a primary amines from the amides, alright, so the C double bond O will be reduced into CH2. For example, okay, so this is our C double bond O group, alright, so just copy back our structure. Here we have the CH3, CH2, and then the C double bond O will be reduced into CH2, and then we have the NH2 group. Okay, so this is the formation of primary amines by the reduction of amide. So actually, our amide here is also a primary amide. Okay, so primary amide undergoes reduction will produce a primary amines. Secondary amines will be produced by the reduction of secondary amide by using lithium aluminum hydride followed by water. Okay, so same like before, the C double bond O will be reduced into CH2. Okay, so for our example here, right, so let's highlight the C double bond O and then just copy back our structure. We have CH3, CH2. Okay, then the C double bond O will be reduced into CH2 and then just copy back all of this. Okay, we have NHCH3. So the secondary amide will produce a secondary amines from the reduction of amide by using lithium aluminum hydride followed by water. To form a tertiary amines by reduction of amide, okay, so our amide must be a tertiary amide. Okay, so when we reacted it with lithium aluminum hydride followed by water, okay, so the C double bond O from our tertiary amide will be reduced into CH2. Okay, sama saja. So the C double bond here will be reduced into CH2. So let's copy back our structure. So here we have CH3, CH2. Okay, C double bond O reduced into CH2 and then copy back all together. We have nitrogen, CH3, and then on this nitrogen also we have CH3. Okay, so we got our tertiary amines. The primary aliphatic amines also can be prepared by Hofmann's degradation of amide. Okay, for the Hofmann degradation of amide, kita punya reagent is bromine in sodium hydroxide and water. Alright, so in this reaction, the carbonyl group, alright, C double bond O, will shorten the length of carbon chain by one carbon atom. It means that, okay, dalam kita punya reactor ni, okay, so kita ada C double bond O and then for our product, dah tak ada dah C double bond O. Okay, the C double bond O tu kita memang keluarkan terus. So, dia akan kekurangan satu carbon. Okay, for example here, right, this is our amide. Okay, so dia still daripada our amide. Okay, dia mesti datang daripada primary amide. Okay, so here we have a primary amide. Alright, so the product will be, okay, CH3, CH2 and then the C double bond O terus dia keluarkan and then here terus dia sambungkan dengan NH2. So as you can see here, our reactant got 3 carbon but then the product will got only 2 carbon. Okay, so the number of carbon will be reduced by 1 carbon atom. The formation of the primary aromatics amines by Hofmann degradation of amide. So, dia sama je macam primary aliphatic amines tadi. Okay, so in this reaction, the C double bond O, dia akan hilang. So, our product will be shortened by 1 carbon atoms. Okay, so dekat sini dah tak ada carbon between the benzene and our amino group. Aniline also can be prepared by the reduction of nitro compound using zinc in acidic solution or tin 2 chloride in acidic solution or ferrum in acidic solution. The nitro group NO2 will be reduced into amino group NH2. So basically, aniline can be prepared from benzene. Okay, if we have, okay, here a nitrobenzene. Okay, so here we have a nitrobenzene. Alright, so the NO2 group. Okay, and then use the zinc in acidic condition, zinc H+, right? So the NO2 will be reduced into NH2 and then since benzene can produce a nitrobenzene from the nitration reaction. Okay, kita ada nitration of benzene di mana here we use the nitric acid HNO3 in H2SO4. Okay, acid catalyst, sulfuric acid. Okay, condition 50 to 55 degrees Celsius. Okay, so nitration of benzene akan produce nitrobenzene and then reduction of nitrobenzene will produce an aniline.